Alright, so we got two lessons here. This one is, make it bigger, interpreting expressions. I mean, there's not a whole lot on this one. Let me move this over here out of the way. A lot of what it is given an expression or an equation, just trying to determine what some of those variables mean. If I can get it pulled up. I think I can make it bigger. No, sorry guys, I can't make this one larger. I can zoom in when we do the problems, but on this one I can't zoom in. These things we did the other day, the properties of exponents, where when you multiply a power to a power, like a power raised to a power, you just multiply those things. And then when you multiply things, you add their exponents. I'm not quite sure why they don't put the other one out here. What do you do when you divide? Subtract the exponents, you make better. Subtract the exponents. I don't know why they didn't put that one on there, but they did. This is the exponential growth and decay formula, that y equals ab to the x, and these are, this one particularly, you should have gone over with Mr. Watson. A is that initial value, wherever it starts, like if you are, I need to put the Chromebooks up for now, because we're not doing anything on the Chromebooks at this point, so you're going to close them up. Yeah. I'm not trying to be ugly, but if I let you look at it, I gotta let everybody else. If you wanna stood up. Because I might be able to trust you, but I can't trust everybody else, that's the problem. So if you wanna move up, you can. Yes. Well, it might be, but it's not gonna make it any bigger, so it doesn't matter. And considering you can't keep your eyes open anyway at this point.
I was out of my eyes for close to
Okay, well, that's great. I can't do anything about that, so, you know, I might have had a bad night too, but I'm here, so, you know, that's life. That's life is life, you gotta deal with it. So if you're gonna sleep, go to Mr. Brantley or go to the office, one of the two. I mean, that's your choices. You know, this is life, and you all make choices. And I don't know if that helps me, but I'm not trying to be ugly to you, it's just the way it is. Anyway, back to where I was going right here. A is the initial value. This would be something like if you deposited money in a savings account, and then they talk about the growth rate, where the rate, maybe you get 5% on your growth rate on your savings account, so it would be 0.05%, and maybe you might compound it for 12. You don't have a savings account where you put money into it, or maybe your parents have a credit card account where they might go buy something for $2,000, and their interest, what the credit card charges them, might be, usually credit cards are anywhere from 15 to 25%, depending on what the APR is. So y'all do know that if you go, once you get out of school and you're out on your own and you have a credit card, making that minimum payment, if they say, hey, you just make the minimum payment, you're good. You're never going to get that credit card paid off. Y'all understand that? If you go buy something for $1,000, let's say you go buy, say you go buy a computer for college for $1,000, and the credit card's going to send you bills every month, and your minimum payment might be $20, and you're like, oh, this is great. Guess how much you're going to pay by the time you get that paid off? Try about 4 or 5 once you get interest. And that's their scheme. That's what they want. They want you to think, oh, you're paying the minimum amount. You are 20, 25, whatever that minimum amount may be. But that's how they make money. So you want to pay it off as quick as possible. That's how the credit card companies make their money. Just like a car loan. You go buy a car for whatever, $20,000. You're not paying at the end of 5 years $20,000. You're probably paying $26,000 to $30,000, depending on what your interest rate is. Y'all need to think about that. I mean, those are, to me, I feel like y'all should have a real life skills class on stuff like that. You need to know, this is where you're getting screwed, people. This is what happens. Yes, sir?
As long as we get rid of credit cards and stuff, going back to paper money.
Well, I mean, a lot of of people don't have credit cards. I have one credit card, but it has to be paid off every month. So it forces me to pay it off.
I don't get a credit card, but it's only for online something.
Well, some people can't control their spending though. They're like, oh, I'll be the first to tell you, and I'm recording this, and I'd let him hear this. My husband, we had a debit card. We get $20 here, $20 here, $20 here, and by the end of the month, $500 is taken out, and you don't realize it. Because that sucker set up.
Yeah, that's why I get my credit card from my mom.
Yeah, that's why we have one credit card, that's American Express, and it has to be paid off every month.
Is it like gold?
Yeah, it does. But it has to be paid off. It forces me. That when I'm sitting there thinking, like if I was out shopping this weekend, I'm less likely to buy more stuff because I know that stuff has got to be paid off at the end of the month versus, oh, well, that credit card company's gonna let me, carry that balance over and over and over.
Because when the kids see it was like, it rang up, your name came up.
Oh yeah, he's got my credit card too. But he knows he has to, like, tell me when he gets my card. So my card. Oh, yeah, we had a conversation because my card stays usually in my car, or my car's not, but he knows to say, you get in the car and I'll get my statement at the end of the month. I'm like, oh, wait a minute, I need to see. Or I didn't know about those things if the touches the process. What is it? That's the thing you've been split, but is there anything that this card comes, I'm gonna look at my bill, and my bill is $3,000, or whatever, but we use that for everything. Because when you get points, and that's something else you need, it's totally off subject, but you need to know these things, like, that's how we paid for a vacation about 4 years ago, because we use that American Express and we get points, so we pay all our groceries, all our gas, everything goes on the American Express, and when we get paid off, if you get points, there's food on it. So that's how we pay for our hotel for a week, and other weeks with those points. Shop around. If you have one credit card, doctor, I saw direct TV, and said, this is bull crap. You're gonna lower my bill's $140 a month, I can go direct, or to whatever those ones did for $40 a month. So they lowered my bill for 2 years. I'm about to call them again, so it's been about 2 years, and it's back up, so. I think you, as consumers, you gotta know, just like with credit card companies, call them and say, look, if you've got one that has a balance on it with an interest rate, then I'm gonna go over to, maybe you've got a Capital One card, and their interest rate is whatever, 22%, and what's another one? Capital One is like a Visa or a MasterCard, it's just a company, the bank that owns it, and then maybe Chase has credit cards, and you go over to them and say, hey, they've got 22%, I'll transfer my balance if you give me 20%. You gotta know how to work system process. Yeah, you gotta do it. And the way I look at it, what's the harm in asking? Well, I'm gonna do so, well, okay, okay. But I always ask, you don't know. It's like when you go to buy something and I'll tell you this, when I go to Lowe's or somewhere and I wanna buy something, okay, I might buy, like I went and bought a washing machine 2 or 3 years ago, but I wanted that floor model. That floor model had a scratch on the bottom of it. Well, who's looking here about a scratch on the washing machine? Well, I want that one. How much you gonna take off of it when it's got a scratch on it? So when I'm standing there in Lowe's, I'm like, look, dude, that's got a scratch on it. I want that in my house. It looks awful. My washing machine's in a closet. Here's what it looks like. But they knocked $50 off of it because it had a scratch on it. You gotta ask. You never know till you ask. So don't just go into it and, say what they ask. Or don't go to a conference.
Go into those and just like, big scratch across the back later, be like, wow, this has a scratch.
You gotta be careful about stuff like that. You gotta ask.
Free food. I just got hair in my food, where's my free food?
Oh, that's disgusting. I don't do that. I can't.
What? I saw somebody do that, like, going to the drive-thru, they got a plug outside of their car. They're like, oh, I had a plug in my food, I just thought you put that in there. Yeah. Pretty funny.
Hair and food is disgusting. I never, ever send food back. Ever.
Not in a restaurant.
You never send it back. I don't care how bad it is, don't send it back.
cooking oil.
Mm-mm.
How much you do?
No, it's just used to pay for it. No.
That's what the table is.
And I mean, like, if you're out at a restaurant, you know, we went to Cracker Barrel on vacation last year, we stopped at Cracker Barrel, and I get my French toast, and there's this big black hair in the middle of it, and the person was cute, I'm like,
Like, really, really.
and of course, that, you know, that, they won't, they'll offer to give you another plate or take it back, no. You just take that off my bill, I'm not, I wouldn't, get me nothing. But never take it back.
Pretty creative way.
Having worked in, and then I'd be real smart. Having worked in a restaurant, never
I
think
get
to
the
about it.
manager with you.
I don't understand, KFC, like, I have not seen anybody,
I think it's pretty good.
Let me put it to you this way, as a teacher, never can see that. Especially if once the things are working.
why?
Never. Yeah.
All the shit for a top.
Never do that.
Anyway, okay, like this example right here, they've got, John has a savings account that earns 3% interest annually. And he's only deposited $100 into his account, so you've got that $100, that's an initial amount. And then 3%, remember when you put things in, like a percent into, you have to make it into a decimal. So you have to, even if it's a decimal already, you still have to divide it by 100 or move the decimal 2 places. So that's where that 1.03, that 1 plus the rate, 1.03. Says the following section represents his total balance after 2 years. So down here it says if it's compounded quarterly, so it's compounded 4 times a year, how much will he have at the end? And then, okay, wait, the following function represents his total balance after 2 years. So they're just asking you to, you know, sometimes in these problems they're going to say, okay, what does the 100 mean? How much was his growth rate? Those kinds of things. Another example, the population of certain bacteria. If you've had physical science, earth science, if you're doing chemistry, this might come up a lot. Bacteria can grow. This is where, kind of like the zombie apocalypse. If one person is infected, and then that one person infects another person, and those 2 people affect another person. Have y'all ever heard the problem about if I give you a penny and double it every day, would you rather take that or $1,000 at the end of the month? I said, if I give you a penny and I double that amount every day for 1 month, would you rather take that amount or $1,000? If I give you 1 penny, so you have 0.01 cents a day, and I double that amount every day, at the end of 30 days, would you rather have that amount or $1,000?
Hold on. Interest rate low. Right?
It's like that problem where, I roll over the key and then there's the key, you put like a coin on the checkerboard and you double it.
It comes up to almost $10 million. Yep.
It's like
In a
you
month?
do, and you have to
Yeah.
double the 2 and the 4 and then double the 4. Or double the 8.
Well, think about it after, I've got the calculator up right here. If I take 0.01 and I double it, right? So I square it. 0.01 times 0.01. Ah, 0.01 times 2. We'll do that. Okay, so now I got 2 cents, right? So after 2 days I have 2 cents. After 3 days, 4 cents. 4 days, 5 cents. So after 1 week, I got 64 cents. So I did this in my math classes, because this is a great exponential growth. So I gave them $1,000 originally. Said, okay, how many would you take $1,000? So about half of them took $1,000. Okay, now, anybody else want to take that $1,000? So they're thinking they got 64 cents after 1 week. So about another half of them took my $1,000. So there's 1 week. So there's day 8, day 9, day 10, day 11, day 12. So 2 weeks. I got $20.48.
I had about 5 people left in second block, all right? I will make it $10,000. They all took it right then. Everybody had $10,000 after 2 weeks, 2048. So there's page 13, page 14, page 15, page 16, page 17, page 18. So 3 weeks. How much you would have if you doubled, start out with a penny in a month. I'm on day 18 right now. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So I'm up to $1 million right now. I've still got 2 more days left. I think we were at 31 days when we did this, because I said I'll even go 31 days. Day 29, day 30, day 31. $10 million after 31 days.
Not a good month.
I'd even take 30 days, $5 million.
Like, you have to have every time you sign for a whole year, you can have approximately $3,000. People go out around 15 a year.
Oh, I find money every day I run. You walk down the hall and you'll find money.
If you let them tell, remember, what you were talking, that's how things are.
I find little baby things. Tyler, what you doing? I said, what are you doing? And after I asked you to put your Chromebooks up.
Sorry. All right, put it up.
In the following polynomial, identify the terms along with the coefficient and exponent of each term. So the terms are just
Harley.
the things being added
Harley.
up in this polynomial. So the terms here, let me write
You
the
just go through
terms
some
here.
vocabulary
The
activities.
first
You know
term is
already.
3x squared.
Not a
The
long
second
conversation,
term,
isn't it?
it's being added to negative 8x. You might say, hey, wait, isn't it minus 8x? And you could just view that as it's being added to negative 8x. So negative 8x is the second term. And then the third term here is 7. It's called a polynomial. Poly, it has many terms. Or you could view each term as a monomial, as a polynomial with only one term in it. So those are the terms. Now let's think about the coefficients of each of the terms. The coefficient is what's multiplying the power of x, or what's multiplying the x part of the term. So over here, the x part is x squared. That's being multiplied by 3. So 3 is the coefficient on the first term. On the second term, we have negative 8 multiplying x. And we want to be clear, the coefficient isn't just 8, it's negative 8. It's negative 8 that's multiplying x. So that's the coefficient right over here. And here you might say, hey, wait, nothing is multiplying x here. I just have a 7. There is no x. 7 isn't being multiplied by x. But you can think of this as 7 being multiplied by x to the 0, because we know that x to the 0th power is equal to 1. So we would even call this constant, this 7, this would be the coefficient on 7x to the 0. So you could view this as a coefficient. So this is also a coefficient. So let me make it clear. These three things are coefficients. Coefficients. Now the last part, they want us to identify the exponent of each term. So the exponent of this first term is 2. It's being raised to the second power. The exponent of the second term, remember, negative 8x. X is the same thing as x to the first power. So the exponent here is 1. And then on this last term, we already said this is 7 is the same thing as 7x to the 0. So the exponent here on the constant term on 7 is 0. So these are these things right over here. Those are our exponents. Exponents. And we are done.
That was on the interpreting, yeah. The simplifying, and again, this is something you did in Math 1, and then you should have started doing this in the beginning of Math 2. And like I said, I can't increase this any on these lessons. So when it says simplify, you're just adding like terms. So on these, the only like terms, in order for it to be like terms, everything, all these variables and exponents have to be exactly the same. So you can't do anything to this 9xy, but you can add the 9x and the 4x, and that's where that 13x, so you're just adding the coefficients, adding the 9 and the 4, and you just bring down that 9xy down here. So when you're adding, you do not add the exponents. Now on the example 2, they're multiplying, so you multiply the coefficients, so 3 times 3 is where the 9 comes from. And now you're multiplying the exponents, so you are multiplying the terms, so you add the exponents. So that's an x2, and that's an x1, so 2 plus 1 is x3, and you've got y2 and y1, so there's a y3, and z1 and z2 gives you that z3. So just remember, if it doesn't have a number on it, there's still a 1 there. You've got to add in there. Then they start making it a little bit more complicated by here you've got to distribute that 4x. So the first thing, so when you multiply, you add those exponents. So 4x times x, that's the 4x squared. And then 4x, now be careful here, minus the twice. You got a 4 times a negative 6, that's a negative 24, and you do xy. And then 4 times 6, again, 24, and you've got an x. So all they did is distribute, and then they brought down this minus 5xy. So then you've got this negative 24xy and this minus 5xy, or plus negative, however you want to think about it. So negative 24 and negative 5 gives you that negative 29. And this is what I was talking about. They didn't have the rule up there on that very first one. So when you divide, you subtract the exponents. So you just divide the coefficients like normal, 32 divided by 8. But then you say 5 minus 2. And he did one like this last Thursday, I think, when we did it, when he spent a lot of time subtracting. So you say 1 minus 1, you got a 1 on the y and a 1 on the y, so 1 minus 1 cancels out to be 0. If you don't write something to the 0 power, because it's just 1, so it's like cancels out, it's no longer in that answer. And then 3 minus 2 to get 1 here. And if you write the z to the 1, it's okay, but you don't have to. So those are things that you did last week, just reviewing on that. And then, let's see, factoring. Again, something that we covered it a little bit, but it was something that you should have gone through with Mr. Watson. And they just cover one part, the differences of two squares. So on this one, and remember at the very beginning of the semester when we did the perfect squares, we played the I have, who has, or not, I have, who has game, where we worked on the perfect squares, the square root. That's where this comes in. But on the exponents, you take those and divide them by 2. So 4 divided by 2, 4 divided by 2. You're always going to have a minus and a plus. And then the square root of 256 is 16. And again, remember, you're going to have your calculators on the test, so you're not going to have to worry about memorizing those things. Because there's no calculator enacted on the Math 2 test. Same thing here. Square root is 625. And then you divide these by 2. So the first thing they did is take out an x to the 8th, that's UTF, the greatest common factor. Of course, Tyler, you have to be paying attention to know what I'm talking about. So 10 divided by 2, or 10 take out 8, however you wanted to look at it. You take 8 out, you have 2 left. And if you take x to the 8th out here, you just have a 1 left. You got to put that placeholder. So then they did the 625, which was the square root of 625. The whole reason they're doing differences of two squares. They're going to give you perfect squares. 25 and 25, and square root of 1 is 1 and 1. I'm going to give you one more example here. Square root of 36, 6 and 6. Square root of 169, 13 and 13. And then you've got your minus and plus there. So on mean multiply everything by 2? Anytime you have this parentheses, what does it mean? Multiply that out how many times? Twice, because x squared. So you would multiply x plus square root of 13x times x plus square root of 13x. When you have two binomials, how do you multiply those out? What acronym do we use? We use FOIL. We did first and outer and inner and last, and you multiply them out that way. So x times x is going to give you a x squared, and then x times square root of 13x. So just think about, is that square root of 13? Yeah, it's all inside there. That x is on the outside, this x is on the inside of the square root, so you can't combine those. So that's going to be plus x square root of 13x. Same thing here, that x is on the outside, that one's on the inside, square root of 13x. And then when you do those last ones, the square root of 13 times the square root of 13, well that's just the square root of 1, and you multiply. Don't say times 2, you do 13 times 13. Which is 169. Which the square root of 169 is 13. That's really, when you multiply those out, that's square root of 169x squared. Well, the square root of 169 is 13. And remember, we did do these. There's a 2 right there, and 2 divided by 2 is 1. So you get that. But then these two will combine. So you got 1 here and 1 here. So that gives you 2x square root of 13x plus 13x. But one of the things I would tell you on this is, anytime you're multiplying binomials and they're not a minus and a plus, the only time something's going to cancel is if they're a minus and a plus. So your answer has to have 3 terms in it. So there's no way something's going to cancel if you don't have a minus and a plus. So if it just has a plus, then that marks out B and D. So those are 2 terms, and then otherwise you're going to have 3 terms. I'm going to go through these a little bit quicker though. Alright, so that's the difference of 2 squares. You got a 1 and a 1. And then, remember I said take that and divide it by 2. So 8 divided by 2, there's your 4, 4, 4, 4. And I said one is going to be a plus and one's going to be a minus. So you're looking at C. A.
Yeah, you specified all the way down to 1
This one right here. This is the very beginning. But then this right here can go further maybe?
Yeah.
So what does that go down to? A is what y'all say?
Yeah. It's not ugly.
It is of what happens. You start out with this one, x to the 8th minus y to the 8th. So then we said, okay, that's x4 minus y4, x4 plus y4, right?
Yeah.
Oh yeah, we got it. Well, that can be simplified further. It's got a minus on it, and 4 and 4 are even, so that's x2 plus y2, x2 minus y2, and you bring that down. Oh, well, I'm through now. Well, that one can be simplified further, because it has a minus on it and even numbers. So that one is x1 minus y1. You can put the ones on if you want. X plus y, and we have that and that. So that's a trick one, but one that they could possibly give you. If you have a question about it, take your answers and multiply them out, work backwards, and see which one gives you that answer. Alright, so same kind of idea. These I can blow up. Maybe that'll, yeah, so what do we think? Now look at your answers to begin with. What does every one of those answers have out in front of them? An x squared. So they took out a GCF of x squared. So if you start out with 81x to the 6 minus x squared, and you take out an x squared, what does that leave you with inside? Well, it's still 81. Now, wait a minute. We had 6. We took 2 out, so how many do we have left? 4. And we had 2 and we took 2 out. So we don't have any x's left, but we got to leave that placeholder there. So now what's that 81x to the 4th? Or is that our answer? I mean, that's one of the answers. But will that break down further? Is 81 a perfect square? Is 1 a perfect square? Is 4 even? Yeah. So the square root of 81 though. 9x 2 minus 1, and then 9x2 plus 1. Alright, is that our answer, or will something else break down? That one will break down. So that's square root of 9, 3x plus 1, 3x minus 1, and then 9. Is that an answer? Yeah. You'll have one of these on your test, I promise you. You'll have one on there. But here's the word. Here's what gets them out of it completely. Factor it completely. Because that was factored, but factoring completely has to be that one. So, today. Alright, now you're just simplifying. So you've got to distribute here. So you know 3y times 3y is 9y squared. So that marks out that one. So that means it's not, well, it's kind of hot. Oh, let me hot. Not that one. So 9y squared. So 3y times 3y is 9y squared. And then 3y times minus 3 minus 9y. And then plus 3y. So we distributed and got those two. Now will those two combine? Yeah, so negative 9 and plus 3 is negative 6y. So which ones are going to be? Negative 6y. Alright, see if you can figure that one out. Again, look at your answers. Look at your answers. Get a hint from your answers. What should we do first? What should we do first? Look at your answers. What do 3 of the answers share? They have an x6, don't they? So we should probably take out an x6, and when we do that, what do we have left? 54x squared minus, I had 6, and I took 6 out. Now, will that go further, though?
Maybe.
That'll be the x6, what's the square root of 54? It's 8x plus 1, 8x minus 1. So, B? And now, that's not a minus, that's m to the negative 6. So first think about this. 8 divided by 4 is what? 2. So that marks out this one, right? And there's a 2 there, a 2 there, a 2 there. Alright, now remember, when you divide, you subtract. So negative 6 minus 4 is what? Negative 10. But you can't have a negative, so that means, what did we do last week? We put it in the denominator, so m10. This one right here wouldn't be correct. Why? Because they have a negative exponent. So that answers out. So then you're looking at this one and this one, but negative 6 minus 4,
negative 10. Well, you can't have a negative, so you put it in the bottom, so that doesn't work out either one of those. So now 6 minus 3 is 3. 6, no, the 10, M10 is in the bottom. So it's either this one or this one.
So we marked out.
And we marked out C, because I had a 2, so our answer should be this one, huh? Now, here's another one of those differences of 2 squares. Is it B? No, it is not B. Think about it, what's x4 minus 81? So that's x2 plus 9, x2 minus 9. That one won't go any further, so that's a plus. That one will though, that's x plus 3x minus 3. We can have that. It doesn't matter what order you put it in. So D. Well, if you're paying attention, you should. Alright, 2 or 3 ways you can go about this. You can distribute that 5 first and then divide everything by 10, or that 5 over 10 reduces to what? 1/2, because the bigger number's in the bottom, so that's really x plus 3y plus y over 2, right? X, so that was a 5 and a 10. So now can I combine those? Oh, that's x. Sorry. So 1x and 3x is 4x plus y over 2.
Yeah.
Okay. Difference of 2 squares. So what's the first part gonna be? 3x, so 3x plus and 3x minus. So what's the last part? 7y. Alright, now all these minuses we've been simplifying further, but are 3 and 7 perfect squares? So that should be it. See? Last one. Okay, first thing, simplify that numerator. So multiply there. So 5 times negative 9 is negative 45. And you've got 2 x's and 4 x's. So what do you do to the exponents? Add them, so that's x 6. 7 y's. Oh, there's no other y's, are there? 7 y's and z to the negative 2 over y9 z3. Okay, so still negative 45. There's no x's to simplify. 7 minus 9 is negative 2, but we don't want negative, so that goes to the bottom. What's not negative 2? It's y2. And negative 2 minus 3 is negative 5, but we got to put it in the bottom so it's not negative. Let's do it that way. D. Pretty good. Alright, now, on your homework, you should have 2 things, because we have to catch back up. Alright, so you've got interpret and simplify expressions right here. Now, hold on, let me go back and edit this though, because we were supposed to have done this Friday and we didn't. Alright, so it's going to say interpret and simplify expressions homework. So there's going to be 2 of them. The interpret one and the simplify one. So remember, you got to do 10 questions. And then remember, if you've gone back and redone any of these, you gotta let me, don't I need to change that one.
kind of said, you know, if you're doing or not doing, right here is what I'm looking at. Whether you're doing or not doing, it gives me what number and everything, so.